So hi guys, good evening. So welcome you guys to another front-end session. So for the today's session, today the topic is beyond monoliths, micro-frontend architecture. So before I start the session, I got this topic I was researching for about this topic for like few days ago. So I hope that this would be an interesting topic for you all of you guys. So let's get started. So the first thing is, before we dive into the micro-frontend architecture, we have to know about the monolithic architecture. I know that you all know about the monolithic architecture. So basically the monolithic architecture is it's a traditional software design where we place all the components of a front-end application, its business logic as well as data access layers and everything into a tightly packed single unified code base. So that's basically the monolithic architecture. So as you can see, as of the image, there's a website called xyz.com, and when we go to the code base of that website, homepage, products, user profile and cart all are tightly packed into a single code base. So apart from monolithic architecture, we all know that monolithic architecture has advantages as well as disadvantages. Before we go into the disadvantages or the issues with the monolithic architecture, I would like to explain about the advantages of the monolithic architecture. So when it comes to monolithic architecture, the first thing we get into mind is its simplicity. So it's simple for the deployments, developments, testing as well as debugging, all sort of things. It is much more simple than micro-frontend architecture, and it has a unified environment, centralized management, as well as it has lower initial costs. So even though monolithic architecture is much more advantageous, but at some point organizations and communities can't use it because the issue is, let's imagine our company grows and grows. We recruit much more developers, like 100,000 developers, and our code base, we are assigning those new developers into one single project, and let's say that project will get 100 plus developers. So if they are using the monolithic architecture, they have to use the single code base. So it will create a much more mess. So there will be blockers with code merging and everything, and some teams might not familiar with the code, the architecture we are going to use. So different teams have different types of knowledge about different architectures, and also it will, when we do the code deployment, it will take much more time, like 30 minutes or 40 minutes, and small changes require entire application rebuilding process. So in these cases, our micro-frontend architecture comes in. So what happens in micro-frontend is, if you have a large scale application, much more multiple autonomous teams, as well as if you need independent deployment without like dependency between other components, and if you have a long-term product vision, so the micro-frontend will be a great choice for it. So what is a micro-frontend architecture? So I can define micro-frontend architecture as it's a software development approach where we decouple, or we break down a single application into multiple components, like products, cart and everything. Components will be handled individually in separate front ends. So it will create a smaller, independent and self-contained modules. So this is also inspired by the microservice pattern in backends, and it will allow multiple teams to work simultaneously and independently without having a blocker with others, or they don't have to stay blocked with their code merger. So there's nothing, disruptions will be lowered. And as of the image, you can see that host application will get products, profile, cards from their separate micro frontends. So that's how basically a micro-frontend architecture works. Apart from that, there are a few actually nowadays micro-frontend architecture is coming to a trend. So these applications have their micro-frontend architectures on their own. So for example, Netflix, their platform is divided into homepage, search and user profile settings, and each of these modules have separate micro-frontends, and it will enable faster loading times, and each section can be cached or updated independently. So it will allow rapid development cycles due to these scenarios. And Spotify has also different micro front-end architectures, and they are search, player, playlist and artist pages, also albums even, they are deployed independently in separate micro front-ends. So because of that, they also have like a design system to maintain the consistency throughout the application. And after that we have Zalando which has 200 plus teams and 1000 plus developers. So they have their sections like products, product pages and checkout recommendations are divided into independent micro frontends. So their teams can use different frameworks based on their needs. So likewise, if one team knows about Vue.js and other team knows about Svelte and other knows about React, so with micro frontend there's no hesitation to work with them. And with IKEA, they have product catalog, shopping cart and customer accounts in separate micro frontends, and they have independent release cycles also. So that's how the things that we use day to day works with micro frontend architecture. Apart from that, micro frontend architecture has several patterns. So like mainly there are 5 patterns that are currently used and managed. So apart from them, the most popular one is module federation, and which will be the one that one will be the demonstration part which will be done by me. And so if I give you a quick head start about module federation, which is a plugin of Webpack, and the module federation has a modern runtime integration with shared dependencies. So it will create the micro frontends to load more quickly at the runtime, and it will share the common libraries among them, and it will work with any frameworks. As I said, like it will work with Vue.js, React.js, and all those things will be displayed in the host without any without any changes or without any disruptions. So the downside is that it is tied to Webpack. So that's the only downside, but it will be a best approach for modern apps with unified build tools. Apart from that, we have iframe composition, which is a much more simple implementation than the modular federation, and it has a total separation from each of the micro frontends. So the downside is it will have a poor SEO and performance overhead. So that's the downside of the iframe composition. But apart from that, it will be a simple implementation for legacy systems and strict security boundaries. And we have the third pattern called web components. So for the web components, it is a standard-based native browser technology where it is built into modern web browsers. Like it has custom elements and shadow DOM, and it's framework agnostic and much reusable. So the downside is like there are a limited tooling ecosystem, and the older browsers require some polyfills. It's like polyfills like for example, let's say one application, one phone, you buy a phone which is a much more older phone which doesn't have a flashlight, but it will get a feature in a few days, like it will increase the screen brightness to act it as a flashlight. So that's the basic idea about a polyfill. So in the web components case, which is also a framework, which has a best approach for design systems and cross framework components. Then the fourth one is build time composition, npm package. This is much more common for us. Like we all work with npm packages, and so it's a simple method model where we just import packages and directly use them. So one downside is it will require host app rebuild, and there might be version mismatches, and it will create some complexity. So it will be a best approach for shared UI libraries and monorepo setups. Monorepos are also like these days currently trending with like equal like frameworks we can use in a simple repo now. So we can use this build time composition packages. And the last one is server side composition. So it will assemble pages on the server side before sending to the browser. So it basically we can achieve this through like server side rendering in let's say if we are using Next.js, so we can perform both server side and client side rendering. So server side rendering will give you increased server complexity and good SEO, as well as it will create a less dynamic nature with the client side. So the best approach is content sites and progressive enhancements. So apart from that, like now I have given you guys 5 types of patterns in the micro-frontend architecture. So when it comes to the need that we need to use we have to choose the right pattern for the our product or the project. So if we are focusing on independent deployments, the best pattern will be module federation or iframes. And if it's a SEO critical content, server side composition will be the best approach. And for maximum reusability, web components, so we can use these components again and again throughout our project. And for simplicity and type safety, build time or npm packages will be the best approach. And for legacy integrations, iframes will be the best approach, but it will reduce the SEO in your project or the front end. Apart from that, now I will give you guys a brief overview about what is module federation, or this, which is a plugin from the Webpack. So basically in module federation, what we do is we expose our applications and consume those modules at the host, and without bundling them together during the runtime process. So basically the host application will handle the navigation, layout, authentication, but the micro frontends or the remote applications will handle their products, their cards or profile separately. So host application is released from the products checkout profile. They are handled by different teams, like 3 teams, and host application is handled by another team. So 4 teams can work together without any disruptions. So the difference between the host and the remote, the host will have the main application container, which we use to handle the navigation, authentication, and the layout patterns. So for the it performs the loading and the orchestration of these remote modules, but for the remote modules, they have independent applications, like they are not dependent on each other. So the only thing is host reuses these remotes as it wants, and it can run remotes can run standalone and consume shared dependencies from the host.